In this video, we solve problem 8.R.031 from the Larson and Edwards Calculus Early Transcendental Functions text. We're asked to use trig substitution to find or evaluate the integral and use capital C for the constant of integration. So I look at this and I see that x squared plus 4, or 4 plus x squared, and I'm reminded of the arctangent function. So since it looks kind of like an arctangent antiderivative, but isn't an arctangent antiderivative, I'm going to make the tangent substitution. Now, if you look at that and you think, that doesn't look anything like an arctangent to me, that's okay. If you are working on a trig substitution problem in our class, you're able to use your reference sheet. So I'm going to share my screen with you and show you the sheet that you are able to use during the exam. So we go over here, we're on our Blackboard site now. And you've got all of your units, discussion questions, and then you've got Unit 1 exam information and exam submission Dropbox. So here's the exam information, and then you've got links to all of your reference sheets. So the reference sheet that we need is the trig substitution reference sheet. So that's this one here. And it tells you what to do. It says, for integrals involving a squared minus x squared, make a sign substitution, because that kind of looks like our arc sign integrand. Or if the integrand involves an a squared plus x squared, that is where you make a tangent substitution, because it kind of looks like our tangent or our inverse tangent integrand. So when I look at this problem, I either think of that myself, or if I don't remember what to do, I always refer to my sheet, and my sheet will remind me what to do. So I see the a squared plus x squared. And that means we know that we're going to let x equal a times tangent of theta. Now you should always check and ask yourself if basic rules apply first. We've got a quotient, so no, they don't. And then I would say to myself, does u substitution work? Well, the derivative of this expression under the radical is 2x, and I've got an x cubed up here. So u substitution doesn't work. In that case, I would try my other methods. And because of the square root of a squared plus x squared, I would use a trig substitution. And in particular, I'd use the tangent substitution because it has the a squared plus x squared. So we'll identify a. Say a squared is 4. So that means that a is the square root of 4, or 2. You want to let x equal a tangent of theta. And then we want to compute dx. And then we want to evaluate and simplify that radical expression. So you can simplify 4 plus x squared, or you can simplify the square root of 4 plus x squared. But the idea is we want all of these guys in terms of theta. So we'll let x equal a, which is 2, times tangent of theta. Dx is the derivative of that. Derivative of tangent of theta is secant squared theta. And then we want to compute 4 plus x squared. So we're replacing x with 2 tangent of theta. So we need to square the 2, square the tangent. Factor out that 4. And 1 plus tangent squared is secant squared. So we'll use that identity here. And then we can take the square root of each of those factors separately. The square root of 4 is 2, and the square root of secant squared is just secant of theta. Now this is what I like to call the prepare to substitute step. Once we recognize that we want to use trig substitution, we're basically identifying what our substitution should be, and we're getting all of these things computed so that we can write this integral entirely in terms of x. So the next step is to write the integral, or not in terms of x, excuse me, in terms of theta. The next step is to write the integral in terms of theta. And the whole point of that is to be able to anti-differentiate it. So we're going to write the integral in terms of theta by substituting appropriately, simplifying, and then we also want to anti-differentiate. Because we can't anti-differentiate this guy in its current form, the whole point of trig substitution is to make it possible for us to anti-differentiate the function. So we've got this x cubed over this square root times dx. So you want to replace x with whatever it is in terms of theta. So x was 2 tangent of theta. So I'm going to substitute that in right here. Instead of x cubed, I've got 2 tangent of theta cubed. And the denominator is that square root. The square root of 4 plus x squared is 2 secant of theta. And you see the mistake I made? I forgot to write my dx. Don't want to do that here. If you forget the dx, you're going to have the wrong integrand. Dx needs to be substituted as well. If x is equal to 2 tangent of theta, dx is 2 secant squared theta d theta. So we simplify where we can. The 2's reduce. One of the secants will reduce. And we're left with this. I've got 2 cubed, which is 8. Tangent cubed of theta is right there. And then secant of theta is multiplying that. And then we evaluate this using whatever methods we like. But if you don't know what to do, you see powers of secant and tangent, you can always go to your trig integrals reference sheets. So let's go to the reference sheet again. I'm going to share my screen with you. So I actually don't want this one this time. I want to go back to content, and we've got our reference sheet for trigonometric integrals. That's right there. And you've got your guidelines for powers of sine and cosine right here. And then your guidelines for powers of secant and tangent. And the second one says if the power of tangent is odd and positive, let u equal secant of whatever your variable is. And then your du will have a secant and tangent in it. So you want to factor out a secant times tangent for your du. So that's the plan. I say I've got the power of tangent, which is odd and positive. So I'm going to factor out a secant of theta times tangent of theta for du. And we're going to let u equal secant of theta. And du, in that case, is secant of theta tangent of theta, d theta. I'm going to write on the side over here what we're doing. You might want to use your trig integrals guidelines if necessary. Okay, so we know to do this. I had tangent cubed, so now I've got a tangent squared here and an extra tangent there. I factored out the secant of theta as well because I needed that for the du. Now everything else that's left over here in the brackets needs to be written entirely in terms of u. This piece is our du. And everything there needs to be written in terms of u as well. Well, it's tangent squared, and I don't have, well, tangent squared is not in terms of secant yet, but I do know a relationship between tangent and secant. We've got this Pythagorean identity. It tells us that tangent squared plus 1 is equal to secant squared. So that means that tangent squared must be equal to secant squared minus 1. So this is actually secant squared minus 1. Secant squared of theta minus 1. And if u is secant, that's u squared minus 1. So this integral becomes 8 times the function u squared minus 1. And we've got a du on the far right. And now we're ready to anti-differentiate. So you can bring your 8 down and then add 1 to the exponent and divide by the new exponent. And the antiderivative of 1 with respect to u is just u, and then add c. And then the last thing we do to finish the antidifferentiation is we write everything entirely in terms of the variable u. So we write everything in terms of secant of theta. If you want, you can distribute that 8 as well. So we'll have 8 over 3 times secant of theta, quantity cubed. You can call it secant cubed theta, same thing, minus 8 times secant of theta plus c. So we prepare to substitute. Then after we prepare to substitute, we substitute. We write the integral in terms of theta. We substitute, simplify, and anti-differentiate. And now we've got this answer, but we need to go back to x. We want to write everything in terms of x, not theta. So we need these functions in terms of x instead of theta, and to find those functions in terms of x instead of theta, we usually draw triangles using our original substitution. So let's do that on the next page. My original substitution was x equals 2 tangent of theta. And that means that tangent of theta must be x divided by 2 if I solve for that tangent function. If I draw a right triangle now, and remembering my right triangle trig, remember that tangent is opposite over adjacent. I have, if this is theta, the side opposite theta must be x, and the side adjacent to theta must be 2. And this side squared plus this side squared equals that side squared. So that third side must be 4 plus the square root of 4 plus x squared. Now, our answer here had secants in it, so I need to use this triangle now to find the secant of theta. Secant is 1 over cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent. So I've got the square root of 4 plus x squared, that's my hypotenuse, over my adjacent side, which is 2. That's our third step. We draw a triangle. We use the triangle to write all of the functions in our antiderivative, which in this case includes just the secant function. In terms of the original variable x. And then the last thing we do is we back substitute. So you write your antiderivative in terms of x. Rather than theta. So you already have it in terms of theta. So we had this integral at the beginning. It's an antiderivative. We wanted to know what function can we take the derivative of that will give us this back. Well, we did a trig substitution. That trig substitution led to a trig integration, and that trig integration led to this result. I think I'm going to write it like this now. That's secant of theta quantity cubed minus 8 secant of theta plus c. And we want to write this entirely in terms of x now. Well, secant of theta in terms of x is the square root of 4 plus x squared divided by 2. So I just substitute that in, and then I simplify. So this is 4 plus x squared to the 1/2 power. We're cubing it. So if I have something to the 1/2 and I raise it to the 3rd power, you multiply the exponents. It's going to make that a 3/2 power. And then you cube the 2 as well. That's going to give me an 8 down there. So the 8's reduce, and 8 goes into, or 2 goes into 8 4 times, excuse me. And so we have this, or if you prefer, you can factor out the 1/3. I think I like it better with the 1/3 out front. So you've got 1/3 times 4 plus x squared to the 3/2 minus 4 times the square root of 4 plus x squared plus c. And that's our answer.